Today we're solving some more algebraic equations. And what's different today is that these equations will have variables on both sides. So, what's important to remember is that as long as we follow the same rules we've been following, we shouldn't have any problem. We're going to attach a first step today though, and that is to get all of the variables on one side. So I either need to move the negative 8x or the 4x. Now I can move the negative 8x by adding 8x to both sides, or the negative 4x by subtracting 4x to both sides. It actually doesn't matter which one I do, but I'm going to add 8x to both sides first. On the left, I only have the 7 remaining. On the right, I now have 12x's minus 17. And this looks like some of the problems we've been solving already. My next step is to add 17 to both sides, which gives me 24 equals 12x. And then finally divide both sides by 12, giving me x equals 2. And I know that I should check my answer to make sure that it's correct. So that's the basic addition, that's the basic step that we're adding today. We could combine this with some of our other issues that we've had. For instance, when we have the option to distribute or multiply by a reciprocal. Now I could either multiply both sides by 4 in this equation, or I could distribute that 1/4. Now yesterday we neglected to distribute because it would have given us some strange fractions to work with. In this case, when I distribute, we get whole numbers when we take 1/4 of 16 and 1/4 of 60. So I'm just going to go ahead and distribute, giving me 4x and 15 on the right hand side. And then I solve it just like I did the last problem. I'm going to start by moving one of the x's. Doesn't matter which. I tend to move whichever one is smaller, which in this case is the 4x. So I'll subtract 4x on both sides. On the left, that brings me down to 5x minus 5. On the right, I'm left with 15. I know that my next step is to add 5 to both sides, giving me 5x equals 20. And then my last step is to divide by 5, leaving me with x equals 4. And of course, I should go back and check my answer. Let's try a word problem. A car dealership sold 78 new cars and 67 used cars this year. The number of new cars sold by the dealership has been increasing by 6 cars each year. The number of used cars sold by the dealership has been decreasing by 4 cars per year. If these trends continue, in how many years will the number of new cars be sold? Number of new cars sold be twice the number of used cars sold. So I know that my new cars start with 78 this year, and they're going up 6 times however many years have passed. So there's my expression for the number of new cars being sold each year. For the old cars, it's starting at 67, but it's decreasing, so I'm going to subtract 4 cars times the number of years it's been going on. And what I want to know is I want to know when twice the number of used cars equals the number of new cars. So I'm going to put it times 2 over here. Okay, that way I'll know when the new cars equal twice the old cars. So I'm going to use the distributive property here. I could multiply both sides by 1/2 if I wanted to, but I'm just going to distribute. I get 78 plus 6x equals 134 minus 8x. My next step is get all the x's at one side. So we can move the 6x with a negative 8x. Now just to show you that it doesn't actually matter, I'm going to move the 6x. Since it's positive 6x, I subtract, leaving me with 78 equals 134 minus 14x. Now, to get that x by itself, I need to move the 134. So I subtract that from both sides because it's positive 134. On the right, I have negative 14x. On the left, I have negative 56. So my last step is divide both sides by negative 14, and that will give me x equals 4. So after 4 years, there will be twice as many new cars sold as used cars sold. Now, not every equation has just one solution, and not every equation has a solution at all. For instance, if I'm given this equation, to solve. And I start by using my distributive property. Let's take a second and think about what this says. 3 times a number is equal to 3 times that same number plus 12. Well, that doesn't make sense. How could you add 12 to something and still get the same amount? But just to ensure that we're thinking about this correctly, if we took our next step to subtract 3x from both sides, that would give us 0 on the left and 12 on the right. But 0 doesn't equal 12, and it will never equal 12. So there's no value for x that is a solution of this equation. Nothing I could put in for x will make that work. So when I come up with a contradiction like this, where 0 can't equal 12 or 3 can't equal 4, something like that, I have no solution. On the other hand, if I had an equation like this, and I did my distributive property on the right, now I have 2x plus 10 equals 2 times x plus 10. And when will 2x plus 10 equal 2x plus 10? Well, for any value of x, that'll work. But if I'm not sure, I could just subtract 2x from both sides, and I'll see that I'll get 10 equals 10. That's always true. So this works for any real number that I put in for x. So my solution is all real numbers. No matter what number we put in for x in the beginning, it's always going to be equal. Alright, so I want you to try a couple problems on your own. The first one we'll give you is 4x minus 5 equals 1/5 times 5x plus 20. And the second one is 13 plus 5x equals 2x minus 8. Would you pause the video, give those a try, and when you think you got the answer, we'll come back and do them together. Okay, so for the left-hand side of the equation, you could multiply both sides by 5, or you could distribute that 1/5, because 1/5 times 5 is just 1, so we got 1x, and 1/5 of 20 is 4. And we want to move all our x's to one side, giving us 3x minus 5 equals 4. Add 5 to both sides, gives us 3x equals 9. We divide both sides by 3 to get x equals 3, and of course we can plug 3 back into the original equation to check our answer. On the right hand side, move that 2x, we're left with 13 plus 3x equals negative 8. Then since that's a positive 13, I'm going to subtract it from both sides, leaving me with 3x equals negative 21. And so dividing both sides by 3 gives me that x equals negative 7. So today we're just throwing on a couple steps. If you're comfortable with it, go ahead and move on to your homework, or you can rewatch the video if you need something else explained again.